This is Dr. Lennon, and we're going to talk about graphs and equations of lines. Probably you're familiar from high school with the slope-intercept form of a line. So it's given by y equals mx plus b. So this is the slope-intercept form of a line. There's many forms of that you can write the equation of a linear function between two variables in, but this is by far the most common. So here m is the slope, and we'll talk a little bit more about that in a second, but it essentially measures the steepness of your line. And the ordered pair is 0, b. This is the y-intercept. So again, slope measures the steepness of the graph of a line. And can be found using any 2 points on the line. 2 distinct points, that is. So let's suppose we had 2 points. So each of those points we would know their coordinates. So we would call them maybe x subscripted with 1, y subscripted with 1, and x subscripted by 2 and y subscripted by 2. These are the 2 points. The slope is given by the formula y2 minus y1 over x2 minus x1. So it's given as the change in the vertical component over the change in the horizontal component. So sometimes you'll see this denoted by delta y over delta x, where that triangle symbol is the capital Greek letter delta. And that's also sometimes written as the rise over the run, just to help you remember that the vertical component should be on the top of the fraction. So one of the first things we can do is if we see an equation in slope-intercept form where we recognize it as a linear equation and we rewrite it in slope-intercept form, we should be able to graph it very quickly. So let's make sure that we can do that. So let's say sketch the graph of y equals 3/5 times x minus 2. So the thing here is to first identify your slope. So your slope is 3/5, and your y-intercept is 0, -2. So then if you have a Cartesian plane, that's all you have to do is first find your y-intercept. So that's where it hits the y-axis, so down here at -2 somewhere. And then you can think of the slope as a way to tell us how to get to another point. So since the top number is 3 and the bottom number is 5, that means if we move up 3 in the vertical direction and to the right 5 from our point that we already have on our line, we should find another point on our line. So if we go up 1, 2, 3 and right 1, 2, 3, 4, 5, then this point should also be on the line. So that is a very fast way to find the sketch of such a line. So we got the coordinates here 0, -2, and here we have 5, 1. So notice if you plug 5 in for x and 1 in for y, you'll get something that's true, right? You'll end up getting 1 equals 1. So I'll leave that for you to check. Okay, so the other natural question is, okay, let's say I have something maybe not in slope-intercept form. How could I change it and then graph it as well? So let's go ahead and look at that. So let's say sketch a graph of 4x minus 3y equals 12. So the first piece of advice I would say is first write in the slope-intercept form, or in y equals mx plus b form. So the easiest way to do that is we're just solving for y. So if we have 4x minus 3y equals 12, the first thing I would do is I would move the 4x to the other side, so we'd have to subtract it to leave the minus 3y all by itself. So we have minus 3y equals minus 4x plus 12. And then to isolate y, that's all we want to do is divide both sides by negative 3. So dividing both sides by negative 3. Now the left-hand side is y, and the right-hand side, remember, negative 3 is a common denominator, so we can change both of those to common to separate terms over the common denominator. So I can have negative 4x over negative 3 plus 12 over negative 3, and then I can write my form as y equals 4 over 3x minus 4. So now we're in slope-intercept form, so we can identify both the slope and the y-intercept. So my slope here is 4 over 3, and my y-intercept is 0, negative 4. So again, I can graph that pretty quickly. So the y-intercept is going to be down 4 spots, and then I want to go up 4 and right 3 to find my second point. So 1, 2, 3, 4 up, and then right 1, 2, 3, we get a second point. So that's the second graph, and we can label the coordinates of these points 0, negative 4, and 3, 0. So actually here we found both the x and the y-intercepts, the places where it touches the two axes. So we can look at the graphs of all possible lines, and it actually comes down to only 4 cases that we can identify completely by looking at the slope of the line. So the 4 possibilities for slope and their related graphs Okay, so the 2 graphs we've seen so far, they both kind of have just a upward shape as you move from left to right, so they look something like this. And in both cases, we saw that the slope was a positive number. If they were descending, going from left to right, rather than ascending, so maybe doing something like this, we would have a slope that is less than 0, so we would have a negative slope. So then the 2 other cases that we could have, if you think about a fraction, a 0 on top of a fraction would mean that the slope would be 0, and a 0 on the bottom of the fraction would mean that the slope would be undefined. So if we would have a graph with a slope of 0, that would actually be parallel with respect to the x-axis. So that would be a slope value of 0. So in this case, the graph of your line will just be y equals some number, right? Because if you look at that line, that might be, say, y equals 2. You might just have all the points where that have a y value of 2, which would all lie on that horizontal line. So I meant to say, e.g., for example, y equals 2. So notice it also touches the y-axis, which means it has to have a y-intercept, and it doesn't ever touch the x-axis, so it has no x-intercept. Whereas if you would have a vertical line, that would correspond to maybe a slope that is undefined. So here we would say m is undefined, because remember, division by 0 is not defined. So maybe on our graph above, we have something like x equals, I don't know, negative 3. That's a vertical line that looks like it's hitting the x-axis at about negative 3. Again, I didn't draw any tick marks, so there's no real scale here. I'm just saying that would be a number that makes sense since it is left of the y-axis. So if you sketch a graph and it doesn't fall into one of those categories with respect to the slope you did, then you kind of have some idea. So maybe some sample problems you might want to try. Let's say pause the video and try. Let me give you 4 problems to try. So let's say A, x equals -4, B, y equals x plus 3, C, y equals -2x minus 1, and D, y equals 7. So go ahead and pause the video and try and sketch those. It shouldn't take you long, maybe 2 or 3 minutes to sketch each one. Okay, so for A here, we have a vertical line that passes through the x value of -4. Let's look at D also. That has a y value, so it should be a horizontal line. Y equals a number. That should pass through the y-intercept at 7. So we get a horizontal line right about here. So I put arrows on the bottom. That just is meant to be the x-axis. So I wasn't putting arrows on the axes before, so I apologize. Okay, then for B we have y equals x plus 3. So we hit the y-axis at 3, and then we would go up 1 over 1. So up 1 over 1 would lead us to this point. So we would get a graph something like this. And then for C, y equals -2x minus 1. We would hit the y-axis at -1, and then -2 over 1 would mean down 2 and right 1. So we would go down 2 and right 1 from that point. So we'd get that point there. So that would be your rough sketch of the graph right there. So very quickly you should be able to sketch the graph of any line based on once you're able to find out its slope. So let's go ahead and look at finding the slope through pairs of points. So if I give you 2 pairs of points, can we use that slope formula to find it? Again, that's pretty straightforward. You just need to make sure that you're identifying the points properly. So let's say find the slope through the given pair of points. Nothing too complicated here. So let's say we have 3, 7 and 5, 13. So you just want to think of the pairs of points identified. So maybe we could think of this one as x1, y1, and this one as x2, y2. Then you just plug them into that slope formula that we talked about. So here we would just have m is equal to 13 minus 7 divided by 5 minus 3, and that should come out to 6 over 2, which is equal to 3. For part B, let's say we have the 2 points -2, 7 and 1, 5. So same thing here again. We're going to do 5 minus 7 divided by 1 minus -2. So be careful when you have those 2 negatives that you're using parentheses and changing that to, again, that's going to be 1 plus 2 now. So we get -2/3 as the slope for part B. For C, we have 11, 9, and sorry, I was actually using the little and symbol, and -4, 9. So here we would have our slope is 9 minus 9 divided by -4 minus 9. So that just leaves me with 0. Oh, sorry, I did the wrong point on the bottom there. This should be a -4 minus 11. minus 4, minus 11. So I should get 0 over negative 15. And when 0 is on top of the fraction, that is a 0. So this is what's going on here. We have a horizontal line passing through the points. You can probably guess what's going to happen in my last example. So let's say we have 4, 1 and 4, 0. Here we end up with m is equal to 0 minus 1 over 4 minus 4, which is negative 1 over 0. So this is undefined. And when our slope is undefined, that means a vertical line passes through the points. All right, so now let's say we want to be able to find the equation of a line that passes through those 2 points. If we can find the slope, we should be able to do that. So let's go ahead and jump right in. So let's say find the equation of the line that passes through (3, 10) and 5, 16. So the first part is just find the slope. So we should be pretty good at that from the last example. So in this case, the slope is going to be 16 minus 10 divided by 5 minus 3. So that comes out to 6 over 2, which is a slope of 3. And then the second step is just plug in either point and solve for b. There's also another version known as point slope form, which amounts to the same thing, so I'll comment on that afterwards, but I think most students nowadays do it using this method. So we know that our equation of our line has to look like y equals 3 times x plus some b value, because we have found that the slope m is actually 3. So now you can plug in either point, either 3, 10 or 5, 16 into x and y, right? Each point represents an x and a y that's on the line. So if you plug those in, you only have one letter left to solve for. So let's plug in 3, 10. So 10 replacing y and 3 replacing x leaves us with 10 is equal to 9 plus b. Subtract 9 from both sides and you get b is equal to 1. So the equation that we found here is y equals 3x plus 1. That would be our answer, because the slope m was 3 and the y-intercept b was 1. So the alternate method for step 2 is point slope form, which is another formula. Again, it's not really necessary for you to use, but you still have to do step 1 the same way, but now you have this formula, y minus y1 equals m times x minus x1, where m is the slope and x1 comma y1 is a point on the line. So it's going to look very similar, but let's say we use the same values here. We would have y minus the y value, which we said to be 10, and then we would have 3 times x minus 3, which was the x value of our point. And then if you solve, you would get the same thing, right? You would distribute your 3, so you'd get 3x minus 9, and then when you add 10, you get the same answer, y equals 3x plus 1. So it's an alternative method of finding the same answer. I don't care which way you do. If you're accustomed to using the point slope form, then go ahead and use it. I'm typically going to just be plugging in and solving for b that way. So let's go ahead and do another couple examples to make sure we have the hang of it. So let's again find the equation of the line that passes through let's say 3, negative 7 and 11, 13. So again, step 1, we want to find the slope. So here our m is 13 minus negative 7 divided by 11 minus 3. So we have 20 over 8. We could simplify that fraction. Both the top and the bottom are divisible by 4, so that's going to be 5 over 2. And then we want to write it as y equals 5 over 2x plus b, which is the y-intercept value we want to solve for. Let's go ahead and plug in 3 for x and negative 7 for y. Usually I just use the smaller numbers because that's going to make arithmetic a bit easier, so you don't have to make use of a calculator. So we have negative 7 equals 15 over 2 plus b. We want to get a common denominator, so negative 7 is the same as negative 14 over 2. And then you want to add or subtract 15 over 2. So if you subtract 15 over 2, negative 14 minus 15 is negative 29 divided by 2. This is our b value. So our answer is y equals 5 over 2x minus 29 over 2. So let's do another example where we're maybe a little bit more explicit about what we have. I think there's a few of these on the homework. Let's say find the equation of the line with slope 1/2 and passing through or just and y-intercept 0, 4. So something like this is much easier than the previous problems we've been doing. We know m is equal to 1/2 and b is equal to 4. So in this case we can just go directly to the answer, y equals 1/2 x plus 4. And we've already finished the problem. So when they give you the slope and the y-intercept directly, there's really nothing more to do. Let's go ahead and talk about parallel and perpendicular lines as one final thing. So So in Euclidean geometry, there's a few ways to define parallel lines. These are lines that don't intersect, or they could both be let's not think too difficult. But yeah, these are distinct lines that do not intersect. So the other relationship that's going to be important is parallel lines have the same slope. So that means do not intersect. Have the same slope value. Whereas if we look at perpendicular lines, so what does a perpendicular line mean? A lot of people will say, oh, these are lines that intersect. No, it's more complicated than that. These are not lines that just intersect. They have to intersect in a special way. They have to intersect at a 90-degree angle. So intersect at a 90-degree angle. Their slopes also have a special relationship. Say they have slopes that are opposite reciprocals. So for instance, let me just make that a little more clear. So e.g., so for example, if a line has slope 3/7, then any perpendicular line must have slope. You want to do the opposite reciprocal. So opposite means the different sign. So this is positive, so the opposite sign is negative, and then you want to flip over the fraction. So the perpendicular slope would be -7/3. So let's go ahead and see how this can be incorporated into some problems. So example, let's find the equation of the line. So we'll do this, do two parts. We'll say A is parallel to y equals 4x plus 3 and passes through -1 comma 8. Okay, so for this one we know m must be the same. Parallel slopes are the same, or parallel slopes are equal. And then we just want to plug in the point we know. So we know our line has to have equation y equals 4x plus b, and then we just want to plug in the values. So 8 replaces y, and -1 replaces x. So we get 8 equals -4 plus b. Add 4 to both sides, so 12 is your y-intercept value. So our line here would be y equals 4x plus 12. So we used the parallel line to find our slope, and then we just plugged in the point, as we often do, to find the value of the y-intercept. So B, let's say, is perpendicular to y equals -1/3 x plus 11 and passes through uh, 2, 1. So now our line is perpendicular to this, so our line has to have the opposite reciprocal slope of negative 1/3. So in this case, our m would be positive 3 over 1, which is just 3. And then our line is going to look like y equals 3x plus b, and we want to plug into 1. So 1 for y and 2 for x. So we have 1 equals 6 plus b, so we want to subtract 6 from both sides. So we get negative 5 is the value of b. So in this case, we have y equals 3x minus 5, and that is the equation. So this one is very similar. We use the fact that our line is perpendicular to discover that the slope was 3. It's the opposite reciprocal of negative 1/3, and then we plugged in the point to find the y-intercept. There's actually a neat proof of this that uses nothing more than the Pythagorean theorem to show that perpendicular lines have slopes that are opposite reciprocal. So I may make an additional supplemental video. Obviously, it wouldn't cover, it would be an optional video, but maybe I would write down the proof of that. So keep your eyes posted for that. Anyway, this is Dr. Lennon signing off.